Okay, so let's start again. And as I told you, now we are going to talk about asynchronous programming in JavaScript. Okay, this will take quite a lot of time because it's really one of the very peculiar things about JavaScript programming, and something that we will use a lot in this course. So we really need to understand it very, very well, okay? Because all interactions between client and server will be asynchronous, okay? And so we need to really understand very well how asynchronous programming in JavaScript works. Okay. So this is quite a big set of slides, okay? So first of all, JavaScript was born as a single-threaded and inherently synchronous programming language, okay? So, in short, when you program in JavaScript, you cannot simply say, well, let's create a thread or a process and let's give it some code to execute, and this code will be executed in parallel to yours, okay? This can be done in other languages, in Java, in C as well, okay? When you fork and then create a new process, and you can, create the code that runs in parallel. Here in JavaScript, you cannot do this, at least, in basic JavaScript, okay? And so, how can we program asynchronously in JavaScript? Well, basically, we have a way to define blocks of code, which are functions, that last time you called callbacks with my colleague. And callbacks because these functions are objects that we can pass around in the code. And so if we give these functions, so these callbacks, to some functions that will execute the function later, so the code later, we have a way to create asynchronous programming systems. Okay? So, for instance, let's make an example. The easiest thing that we can do is create a function that can execute very simple code. Print something, so console log something. But we don't want to do it now. We want to do it at a later time, asynchronously, with respect to the execution of the code that decides to create this piece of asynchronous code, so the print for later. Okay? Well, in a certain sense, it's relatively simple. You have functions, typically system functions, so provided by the environment, to which you pass as a parameter other functions, so what we call callbacks, that will be executed later in time. Okay? When? That depends on which function you are calling. For instance, the most common one is the set timeout. That means that what you pass here, that must be a reference to a function to be executed later, will execute later this function, so we'll call this function later, and you can specify, after which time, after how much time you will execute this function. This is in milliseconds, so it's 2 seconds. And then you have optional parameters, and you can even pass optional parameters that will be passed to the function to be called later. Okay? So very simple stuff. Set timeout, delete after timeout, or whatever name you like, in the form of an arrow function, or whatever type of function you like. Here, arrow doesn't matter, because if you don't have this function or arrow, it doesn't change. Okay? And you do something like console log, for instance. That is the easiest thing to try, programming. So let's try this example. I mean, before going into the rest of the explanation. So we well, very simple stuff. So we practice a little bit. We already created a folder, but I mean that's for later. Okay. So in week 02, there was the example vehicle. Let's create another file, timeout, out.js. Okay. Use strict. Don't forget. Okay, and then we will have this set timeout. Let's call it print something. Okay. Let's get rid of the parameter and const print something and arrow function, right? And console log hello. Okay. Okay. So it's very simple code. I mean, just type the more or less what is written in the slide. Okay. Let's execute it. What's the name in the correct folder? Timeout. You see, it waits for a while and then it prints. Okay. So basically, we gave the system a function to execute later that is this print something. Okay. That on the slide was delete after timeout, whatever you like. And this is executed after a while. And in this case, it's 2 seconds, 2000 milliseconds. Okay, let's try it again. I start, 1, 2, and then hello. Okay, so the function gets executed. How this system works? Well, before going on, we need to understand how this system of calling functions asynchronously is organized in JavaScript. And the answer is this one. This is the execution environment, which is actually very similar both for Node.js and the browser. The browser is the one for which we care more. Okay? But Node.js is very similar. Okay? So there's an execution environment where code gets executed. We already saw this stuff and we'll try another example now. There's a call stack where the code is executed synchronously. A function calls another, the function returns, and so on. So this call stack it becomes full of items. At a certain point when the function returns, it becomes less and less full. At a certain point will be empty. Okay? What happens when it's empty? Well, the system looks into the callback queue if there is something else to execute. Okay? If there is something else to execute, it takes the first item of the callback queue, it puts it on the call stack, so it means it calls the function, it calls the callback, and it starts executing the callback. And it goes on and on until there's something that needs to be executed. Okay? In the browser, even if there's nothing that needs to be executed, I mean, nothing happens. You wait because you're still on the page and you're waiting for something to happen. Okay? In Node.js, either the program terminates because it's a standalone program, or if it's something that is, must be waited for, the program does not terminate as we saw before, because there's a timeout still there, and the environment knows there's a timeout, and then when the callback is put here and it's executed and there's nothing else to wait for, it terminates. Okay? But I mean, terminating in this sense, I mean, it's not so useful for us because then we will program in the browser and the browser will never stop waiting for callbacks to be executed, but because a new callback will be put in the callback queue every time we interact with the page. You click on something, it means you call a callback. and the callback goes in the callback queue, and then it gets executed. Okay? And for the server, that's the same. The server is waiting for incoming connection. So there's nothing to execute until an incoming connection arrives with some data, and the corresponding callback will be put in the callback queue and executed. Okay? And this loop, which is waiting for new callbacks to be executed, is called the event loop. Okay? And when we talk about the event loop, it's the system that waits for something to be executed. And it can be executed only when the call stack is empty. So it means that if JavaScript is executing other code, all the callbacks will wait. Okay, that's a queue. It's like when you go to the post office, there's a queue, you wait for your turn. Okay, let's try an example. Okay, if you click, okay, you need to close this stuff, but there's some code already written here. Okay, that's a set timeout stuff, right? So, you see, console log, part A, no, okay, let's do part B and part C, okay? So, set timeout, we write a function directly as a parameter. You know, these things are quite common in JavaScript. You could have written an arrow function and stuff like that. Okay, it doesn't really matter. The set timeout takes a function to be executed, and it executes it later. Okay, so let's try to run this example. You see that there's a call stack, and before there was a callback queue. We didn't look at the callback queue, but now you know what it is. Okay, and then this rounded arrows that basically it's the event loop. Okay, so let's try it. Part A, set timeout. Part B, we wait for the timeout to elapse, and then part C. Okay, so the order in which things get printed is A, B, and then C. Okay. And the stuff you put here in the set timeout is executed later. So it should go, I'm not sure we saw. Okay, at the end of the timeout. Yeah, it appears below here in the callback queue. Okay. And then it goes in the call stack. Okay. Since the call stack is empty, it's immediately put in the call stack. If you were doing something more complex that I cannot do in the browser, okay, in this small example, you will have waited in the callback queue until the call stack was empty. Okay, see it a third time, and then that's all. So set timeout, then the rest of the code is executed, and when the timeout expires, puts into the callback queue, and it executes the code of timeout. So console log part C. Okay, if you want to try some, simple code here, because this simulator is quite simple, you can try it yourself to understand how things work. Good. So the event loop is the system that basically wait for the call stack to be empty to execute the first function that is in the queue of the callback queue. Okay. So when you write code, you can simply do what you are used to do. So call functions, traditional way of programming. You call a function, it calls another function, it returns, and so on. It does whatever you want. Or you can schedule an asynchronous event. Okay. And to do this, of course, you need a special function like the set timeout. Or maybe you do something that is asynchronous by itself, like you are asking to read something from a file, okay, which is an asynchronous operation. And you don't want to wait for the file to be read, okay? You pass a callback that will be called when the file will be read, okay? Or you wait for a network connection and you pass a callback, and the callback will be called, so put into callback queue and then executed when you have some data that comes from the network and so on. That's the same for all asynchronous operations. Okay, like you register a callback for the press of a button, and the callback will be called when the button is pressed. But that's an asynchronous event because it doesn't depend on the code execution. It depends on something external to the code execution. So at any step, so at any moment, the JavaScript interpreter, if the call stack is not empty, goes on with the execution of the code. So push, pop functions and so on. You call a function, it push something on the call stack and pops when the function returns. Or if the call stack is empty, it picks the head, so the first element of the message or callback queue, and execute it. Okay? Depending on the places where you look for, this is called message or callback queue. It doesn't really matter. Okay? It's just an implementation issue. Note that the function call, or when we will have an event handler that basically callbacks, is never interrupted. So you should avoid writing blocking code, so code that lasts for too much time. Because when you're executing code, if the call stack is not empty, you cannot do anything else. It means we are in the browser, we attach callbacks to the buttons, to the element of the interface, we click, and nothing happens. Because JavaScript is executing other code, not the callback of the button, of what you clicked, and so on. So nothing happens because it's queued. It will happen later, but it will not happen immediately. And this is really bad behavior for the user, right? So when you write JavaScript code for the browser, try to write something which is short and not too complex. And if you need to do complex things that require time, you need to try to write them asynchronously, okay? So that when they are ready to be processed, will be processed, but they don't block the execution of the other parts of the code, so all the other callbacks. Otherwise, your interface will become freezed. This concept is very similar also in other languages. When you have user interfaces, which are typically asynchronous, you want to respond to a synchronous event, that is the user interaction, you have the same mechanism, okay? So it's actually the same. You just need to focus on how JavaScript implements it and how we can write efficient code in this using the support that JavaScript gives to us. Okay? So try to write non-blocking code. Okay? So if you have an intensive chunk of code and you execute it into the browser, it means the browser seems to be frozen. You click and you do things, and it will not answer you because there's just one JavaScript thread that is executed for each browser page. Okay. This may happen outside the browser as well. It will happen in Node.js as well, as we saw before. I mean, we didn't have the browser; we had Node. Especially when you read files, you read data from database, and so on. Okay. But I mean, you will understand this way of programming because it's really the basic of web programming. Okay, so I mean, this is just a warning, but I'm not too worried about this. So, how can we use asynchronous callbacks? Well, asynchronous callbacks are great for simple things like all asynchronous operations by definition, all input-output operations, clicks, button clicks in a browser, fetching a document, reading a file, and so on, handling timers, so things that need to be scheduled later, reading database, and so on, or even reading from the command line, for instance. You can do it in JavaScript, okay? But you see how complex it is. JavaScript was not born to do these things. I mean, to do something like this, well, apart from the fact that you need a package, okay, because I mean, reading from command line is not really, the purpose of JavaScript. You see that this asynchronous operation, that is getting the answer, so what will be written by the user on the command line, will be handled by a callback that we receive as a parameter what is written on the command line by the user. And not to block the execution of the code, if the library is well implemented, okay, so it uses asynchronous programming, it will require you to pass a callback that will be executed when you have the answer from the user. Okay, otherwise you block and you wait for the user to answer. That's what happens in C, basic C, scanf, and then the program blocks there until you get an answer. Okay, that's synchronous programming. Okay, that's not the way in which JavaScript is used efficiently. Okay. So let's go back to timers, the very simplest thing that you can use to do a bit of asynchronous programming. And then we will go to more complex stuff. By the way, that's not useless. I mean, the set timeouts exist in the browser as well. And it can be useful to update something asynchronously in the web interface, in the page. Okay. So like every second you want to update the time, for instance. Okay. There are two primitives available from the JavaScript environment. They're both available in Node and in the browser environment. Set timeout, set interval. Set timeout executes the callback that you pass just once after a certain amount of time. And the set interval runs the callback periodically. Like, as I told you, you need to update the time every second. You can do it, but it's inconvenient to set a set timeout, a new set timeout every time you execute a new function. You can do it, but it's a bit inconvenient. Okay, so that's the example that we saw before, basically, right? So there's a set timeout that takes a function and does a console log after 100 milliseconds. Okay. So what gets printed here is hi and then hey, okay, not the vice versa. Just be careful that we discovered this stuff in a lab a few years ago. I mean, this timeout value is basically implemented as a 32-bit integer with signs, so it means you cannot really schedule stuff for 1 month later. Okay. This was, due to a lab where we asked, to make things colored after, they expired and so on. Basically, it happens that in the implementation, the number rolls over after, you reach this maximum, the number that is the maximum value that can be represented. Okay, but I mean, in practice, it just because we ran into this problem once in the lab. But I mean, you shouldn't really care about this. Also because JavaScript programs are not meant to be to stay there executing code for such a long time. In the browser, JavaScript is executed as long as you stay on the page in the browser. Okay, when you leave the page, everything is cleaned up. So the program is stopped, whatever it's doing. And there might be a problem in a server if you write in JavaScript, but we are using JavaScript in this course for convenience. I'm not really sure if you want to use JavaScript as a language on a server. In case you want to use it, probably it's better to use some libraries that helps you to manage these things if you really need to have these things. Okay. So you can even pass parameters, and these parameters can be passed as from the third parameter on as parameters to the set timeout and also to the set interval function. Okay, will just be copied when the function calls the callback. Okay. So set interval, well, actually this is a bit useless, right? It passes a callback that does nothing, okay? If you want to put a console log here between the braces, the brackets, you see something every 2 seconds, right? And when you set an interval, you need also to have a way to stop it in case you need it, and that's the return value that you can use. ID is an handle that refers to the timer. Actually, don't even care what it is. It's probably a reference to an object. I'm not sure if it's a number. I don't think so. But anyway, I don't really care. It's something that I can use it with another function, clear interval, to stop the calling the callback every 2 seconds in this case. Okay, and so we have callbacks, but when you delegate the execution to a callback, if there is a problem, an error, how do you handle the errors? Because in synchronous code, we know, I mean, it's the return value of a function, or we have additional parameters, whatever, and we can handle errors. We throw exceptions, whatever. With callbacks, how can we handle errors? So how can we get the information about which error happened? Well, actually, there's no official answer or official way of doing this. Okay, there are only best practices, and one of these best practices is to have the first parameter of the callback function to store the information about the error, and the second and the rest is for the result of the operation. This convention is used by many packages and libraries that we will use. Okay, we need to have a way to pass information to the callback, and a way is passing parameters. Okay, and this is typically the strategy adopted by a lot of packages for Node.js. Okay, we will not use read file. This is just an example. Don't use the read file in your code. But just to show you that when you read the file might not exist. You don't have the permission to access the file and so on, all this stuff. Well, it's an asynchronous operation because you need to wait for the file to be read. And when it's finished, this read file will call your callback, and if the error contains something, so it's not null or undefined, or whatever it says the package, we will handle the error, console log or whatever you want. If there's no error, you can use the data that has been read and do whatever you want. Okay? That's a possible way of handling errors, and also one of the most common ways when you have just callbacks for asynchronous operations. And so, before going on, we will see an example on how to perform asynchronous operation, and especially the ones that are useful in this course. Okay, that is accessing information from a database that we will use to develop the project that then you will have to submit for the final exam. Okay, so instead of reading files, which is not needed here, because if we have a database, we have the possibility to store information in a more structured way, more convenient for reading, writing, and so on. We'll see how to handle a database. Okay. This database will be used on the server side of our project. We will develop a project, a server part and a client part during this whole course, starting basically from, I think, next week until the end. And that's more or less what you should do for the exam. Okay, so we will do all the things together, and at the end of the course you will be able to do it yourself, hopefully. So to have a web server that can do something interesting, we need to be able to store information. Okay, otherwise it's really too simple web server to develop something interesting. And to store information, the best thing that we thought for this course is having a persistent database. Okay, and you can access databases of different types, different let's say how you say, companies or developers and so on. through libraries, through packages in our case, okay? And you saw there are 2 million packages, so basically there is a package for any kind of database you might think about, okay? So any type of database is handled by some packages, some good package, I mean. In this course, we will use this SQLite format for database, which is a very, very simple type of database, which is sometimes useful also for, you know, simple applications, because it doesn't require you to start a process, okay? It's just a file. So it's a relational database, so you can use SQL, select, insert, update, delete, all these queries that is used, you know, to query and store and retrieve information from the database. Just writing everything into one file, but that's a package, that's the code of SQLite that will take care of the format of the file. Okay? For us, the important thing is that everything is in single file, so that when we need to move the database, we just move the file, and that's all. Okay? And it's in process in the sense that it's executed in the same environment as our program. Okay? So it's not a separate server to which we talk through the network, even if it's a local network. Okay? As big databases like Oracle, Postgres, MySQL, and so on. Okay? It's just an in process, so it means a library that takes the query and decides how to store the information into the file, and takes the query, the select, and so on, and read the information from the file, gives the information to you in already in the memory, in a data structure in the memory, typically an object. Okay? So how can we use SQLite and the SQLite format for the file that we will use in our example exercises and so on? Well, we search an npm package, and actually there are many that can handle SQLite. We suggest to use this SQLite3. Okay, I should fix that slide. Okay, because it's the simplest one to use. Okay, they differ a little bit on how you should pass the callbacks. If the callbacks are asynchronous, if you need to pass callbacks, if they will return promises, which is something we will talk about later next week, and so on. Okay, but the concept is more or less the same. So basically, we will show you the simplest one, what we think is the easiest one for you to use, and we will do some experiment with this. So first of all, we need to install the package as we did before. Okay, I did it during the break just to make sure everything worked. In case you have problems, in the next lab, you will focus on using this SQLite and doing a bit of asynchronous programming. So in case there are problems, we will help you during the lab. This is a more complex package than Day.js. So it's not like, I typed this npm install SQLite3 and it didn't work. Because it's a more complex package. It requires a part of native code and so on, but if everything works, it will work automatically and you are lucky. If something is wrong, probably you are missing some programs and so on, and ask us and we will try to solve it. Okay? Because basically installing this package the first time requires to compile some C code, C++ code and stuff, okay, to make it efficient. It's not only implemented in JavaScript. Okay? But anyway, this is just a technicality. If everything is fine, you will have the possibility to require SQLite3 as you did with Day.js. And then you have an object, SQLite, that gives you some methods you can call to open the database and to use the database. Okay? And that's the way in which you use the SQLite3. Again, how do I know? I search in the documentation. Okay? That's the best way. Otherwise, you search Google and stuff. But, we will try to give you the pieces of code that help you start working with the database in this case. Okay. You see that DB, new SQLite database. So this is a constructor function. You pass as the first parameter the name of the file. By the way, if it doesn't exist, it will be created. And you pass a callback. And this function has nothing to return in terms of data, but it might return an error. Okay? So you need to do something with the error. Typically, either you print it, so console log, or you throw it. If you throw something and it's not cached by any other part of the code, the Node.js will stop, but it typically prints the error. So for you, it's more or less the same. Okay, like the file is present, but it cannot be opened for some reason, for permission reasons, whatever. Okay? And so just a quick overview how to use it, and then we will try to do an example. Okay, we'll try examples from the slides, basically. Once you open the database, so you are connected to a file where you can store and read information, you can run queries, SQL queries. So on this DB object, you have a set of methods, and the main methods are these ones. First, .all. SQL is a string that contains the SQL statements, so the query. Okay, select a star from table, that's all, and you read the whole table. Okay, params, which are optional, so if there are no params need to be passed. That's an array. Okay, and then there's a callback. This is an asynchronous operation. So in all these functions, there will be a callback to be passed that will be called when the operation, so the query, has been run on the database. And so even for select, it might require some time. You need to access the file, open the file, read the content, and so on. Something which is done by the library. You don't really need to do it yourself. It's done by the library, but it's something that might make you wait. So it's an asynchronous operation. And you need to handle it as an asynchronous operation, passing a callback to be called when it's finished. And the convention here is the one that I said you before. I told you before, like the first parameter is an error, and the second parameter is the data that is returned by the operation, in this case the select query. Okay? So it executes the SQL query and returns all the rows as a parameter to the callback. And in this part here, in the brackets, you can put all the code that you need to handle the result of the query. Okay? If error is true, some error occurred, and so you need to check what happened. Okay? But I mean, typically error shouldn't happen except during development, because if an error happens on the server when you're reading data from the database, it means that you didn't handle the error correctly. Okay? Or you need to handle the error explicitly. So there's no rows, but I mean no rows. I mean typically means it's a possible answer of a select. It means I wrote the wrong name of the table. That's an error, but that's a programming error. It shouldn't happen actually when the program is finished. Okay. Anyway, if everything goes fine, rows contain the result, and rows is an array of objects. Each item contains the fields of the result. Okay. You know that select returns a table. A table is a list of rows. So it's an array of rows. And each row, in this case, is mapped into an object where the key is the column name. Yeah, it's the column name, and the value is the value contained in that column. Okay, that row and column. I think, I mean, that's all the explanation. creating table, querying data, and you search, for examples and so on, right? Okay, this is with promise, but I mean, you can have a look at, examples, and in case you need help, we are here to help. But yeah, I mean, that's the documentation that we hope it's good enough for you to start. We will give you example code, so you can start from those examples. Yeah, for instance, on rows, you learned last time, the functional programming pattern. All arrays in JavaScript have a method for each, and you can pass a callback, a synchronous callback in this case, to be called every time you go to a new element in the array. And here you simply do console log. Okay, row.name, it means there's a column that has name. Okay, so the column name is name, and you can print the element, the property name of the object row, and there's an object for each element in the arrays of rows. Okay, but I mean, you just try, and it's easy to understand. Okay, there are other methods useful for our purposes, like get only the first row. Typically, when you search for a username, you just care if the username exists or not. Okay, you don't want the full list of usernames in your system. Get is fine. Okay, each execute the callback once for each result row. Okay, so it's a bit different from all. You see, it depends on how people developed the package. They thought it would be useful to have both all, so to return the whole table in a single call as a single parameter, or just to have the callback called again every row, especially when you have many rows, for instance. Okay, that depends on you what you want to do. Okay, and then you have run, that works for all the SQL statements which are not select. So it means for insert, update, delete, and all the stuff. Okay. So for statements that do not return a value in terms of a table. Okay. That's something that is returned, so that's the result of the operation. Okay. Okay, just be careful. Here you see function and not an arrow function. You see the function keyword, right? Not the arrow. Notice this stuff. It's a common source of error. But once you fix it, that's all. But during the lab, it might happen you forget. That's because the designer of the SQLite library decided to return information in the function not through a second parameter, but through the this keyword. So the reference to this. Okay. So basically, before calling your function, your callback, inside the library, somebody will do this, binding between an object and the function. Okay. And so inside your code here in the brackets, you can use this dot changes and this dot last id to get the number of affected rows. For instance, update. You update something, and depending on a certain condition, you might have, 3 rows updated. Okay, because they are the ones that refer to whatever you need. Or last ID, number of inserted row ID, typically for insert queries, where the database generates the new ID when you insert a new row. Okay. Note that to make the this object work correctly in the callback, the arrow function syntax cannot be used here. Okay, because it has that behavior which is different. It would be if it this with the arrow, it takes the this from the surrounding scope. Okay, so it means that the this will be where I call db run, which is not what I want. I want this to be set by the code that calls the function, and so I need to use the function keyword to define the function. Okay, so queries. Queries can become complex in terms of SQL, and queries might be parametric, so need to have information coming from external sources when you read and when you write information. So when you select and when you insert, update, and so on. There's a convenient way to use this information coming from outside the query because the library supports this syntax. The question mark for every place where you need to put a value, which cannot be specified when you define the query. So select from course where code equal to, and I don't have the value now, but I need to read it from the code, get it from the code. And this second parameter, you see the array that we saw before, is the place where you can put the element that will correspond in order, first to the first, second to the second, and so on, to the question mark that you use in the query. Okay? This is called, those are called parametric queries. Okay? And that's a way to compose the query, the SQL query. Be careful, never use different ways to compose queries. Why? Because this can be a problem from the security point of view. I'm not sure if you have heard about SQL injection. Okay, that's something that might happen if you don't follow this pattern. We will have slides about this later. Okay. Here we are focusing on the async programming, so make things work first. And then we will discuss briefly about SQL injection. It means having basically values that disrupt the behavior of your query. Okay? Like forcing your query to do two different operations, including, let's say, deleting elements, deleting a table, and stuff like that. If the value is a number, everything is fine. If the value is semicolon delete something, the query will do two operations. Actually, depending on the implementation of the library, but in theory, it might happen that you do operations which are not expected. Okay? Okay. So always use the parametric queries. Of course, you can compose the strings in any ways. I mean, this is JavaScript. This is just a string. You pass a string and you can create the string as you like. But remember, don't use anything different from this system. This system automatically protects you from this problem because it passes the variable part of the query as a separate parameter. So it will not be executed as a part of the commands of the query because it passed separately. Okay? Example, table course. There's a code name, a CFU, so the number of credits, and the score, so they are the marks or the grades, and the date when it's passed, and so on. Okay? Not sure I have this example. Transcripts, no, Q8. Let's see, maybe they just changed the name. Anyway, let's try to write some code that reads this this database. Okay, two tables, course and scores. SQLite requires SQLite3, new SQLite database. There's a database, just that's the file that needs to be in the same folder as where you execute the program, just for convenience. And then you have a query, select stuff from course, left join, score on, etc. DB all, SQLite, and for let row of rows, console log rows. Row, okay? So you print the result if there are no errors. What do you get? Well, you get an array here rows, you do a for of on the array, and for each element on the array of the array, you do console log row, and we say the row is an object, and the key is the column name, and the value is the value on that row in the table. So if we go back, code, and this 01 ty and so on. So code, that's the name of the column, and the first row is 01 ty and so on. And then you have name, cfu, name, cfu, and then you have course code, score, etc., because you did a join, right? Okay? This is normal SQL. What you know about SQL and on databases, it's exactly the same here. Okay? When you do a join, you create a table that has two sets of columns, and so basically you have the keys which corresponds to the new table that is being created by the join. Okay. Let's see what happens in case we don't remember that this function that we pass to the dball is a callback. So it will be executed asynchronously. So before here, we printed inside the callback, so everything was fine. If we think that inside the callback, we should push, so add the row to an array, which initially it's an empty array, and we add the new rows to the array, and then we print the array, what will it happen? I mean, there's nothing wrong in principle with this approach. I mean, instead of just printing, we also add to an array. No problem. What's wrong here? The point is that when you call dball, you don't wait for the callback to be executed. You just go on, and then you print console log stars, and then you execute the for let row of result console log row. And if the callback has not been executed yet, as it will be for sure, because we say JavaScript is single-threaded, you have something else to execute. Okay, the callback maybe already finished, but it's still waiting in the callback queue. Okay, you will print the list of stars, and then you will do the for of on the array, and the array is just empty as you defined it before. And then the code will prosecute, will go on, will wait for the callback to be put in the callback queue, and then you will execute all this code. So at the end, after you printed, after a while, this array will be filled with all the rows. So there's nothing wrong in putting stuff in the array. The array in the end will be filled. But the point is that you don't have a way here at the for, to wait for the callback to be executed. So at this point in this course, at this moment, the only way that we have to adjust things is simply move this code inside here. So, so we go back to the previous example where we printed stuff here, okay? So we have no way to wait for the execution of the callback. We need to remember that this callback is executed asynchronously. Okay? I think the example should be this one. Just SQLite3. Yes, it just has a different name. Okay? Transcript. It doesn't matter. Well, let's put the same name. Transcript. Okay, sorry. So we try it. Okay? Transcript. And then I will commit it so you can try it yourself. Well, you might have noticed I created another folder, db, okay? Because I need to install the SQLite3 library, okay? Which actually I did it during the break. You see how many stuff is present inside the node modules folder, okay? We don't really care. These are all dependencies of the SQLite3 package. That's a more complex package than the JS. It has to do many things. It has to parse SQL, it has to open files, it has to do conversion of format, and a lot of stuff. But we don't really care, okay? So let's start from scratch. So I delete the node modules again, okay? Also the package. Let's assume you start from scratch, you copy and paste it from the slides. So I have this transcript that is the code on the slides. And of course you cannot, inside the DB, yes, you cannot simply execute because there's a part missing, right? Module not found, the SQLite3, okay? So npm install SQLite3. You need to have the network connection and wait a little bit. I hope the network is working. It takes a while. Too much, I don't know. It was faster during the break. Yeah, well, I don't know. Well, it wanted to sleep a little bit. Okay. So actually it added 123 packages, but I mean, we didn't ask for them. They are all dependencies. I mean, everything is managed automatically by the npm package manager, okay? And now we can do this, require SQLite3. And so we can run the transcript. Of course, we need to have the database as well, okay? I already prepared the database, and then I will say something about the database in case it's needed. So, node transcript, and you see that in the beginning we have this empty list. So that's the code that we wrote, right? It's just slightly modified, so you see the end of the list, right? So that's this stars, and then this row of results, okay? And console log, etc. I mean, there's nothing that we print because we have this empty array and it's still empty when we arrive at that point in the code, okay? So how did we print the stuff? Well, actually that's this console log, right? So the one inside the callback. And we have no alternatives for the moment, okay? So let me push this stuff to you exams, right? Let's see if I can do it on the fly. Just to exams. For example, transcript, commit. Why there are no? Okay, push. Let me check first time if this works. So lecture example, week 2, now you have DB, okay, and you have the code, okay? Just in case you want to try. Okay, so asynchronous programming can be, a bit scary at the beginning, right? So that's all the story I told you. Okay, so every query will be executed asynchronously because it requires to access files and so on, and we don't like that asynchronous operations block the execution because it means everything is blocked. JavaScript is blocked. Okay, and you will see other examples. I will commit them at the end of the lecture. Okay, So this is a very simple stuff, like you see, db run, insert into numbers, number values 1, so just a fixed value, and select count star, so tell me how many rows are present, okay? And console log rows 0 dot as dot, because I gave the name dot, okay? Queries, okay? And you will see that the numbers are not in order. Why are not in order? Because these operations are executed asynchronously. Okay, let's try. So the queries. Yes. So node queries. You see the result. You see 999999. Okay, 81, 82, 82, 82, and so on. You can try it yourself. Okay, you will try yourself once I give you the code. Operations are executed asynchronous means we don't know the order of execution. Okay, and we need to be prepared to any order of execution. That's the principle of asynchronous programming. Okay. So how can we fix a situation like this? Well, it's difficult. Because previous case, we fixed it by putting the code that needs to be executed later inside the callback. Right? So the console log, the for, was inside the callback. But here, we need to have more things. So we should put one code inside the other one, right? So, and you cannot do it, right? There's a solution. I will commit the solution, but it's not recommended. It's really a trick. Okay, I will not show it to you here during the lecture because I think it will confuse the ideas. Okay, and so this leads us to the concept that we will discuss in details next time of promises. That is a way to solve this problem in an elegant way. Okay, so that basically gives you a value that stands there while you are waiting for the actual value resulting from the execution of the asynchronous operation. Okay? So, the problem is that if we need to wait for the execution of a callback, either we put the code inside the code of the callback, and so we are sure it will be executed after the callback is called, or we need to find an alternative way. But when you have a lot of callbacks, you will have the so-called callback hell. Okay? So things get nested, and sometimes cannot even be nested easily, as in the previous case. Okay? And so the promises, which are common to other languages have similar concepts, are a language feature of modern JavaScript to simplify asynchronous programming. Without promises, it will be quite difficult to write asynchronous code. Okay, which solves the problem of the callback hell, and also they are the basis of a couple of new keywords, async and await, that we will see later in the slides, which have been introduced in more recent version of JavaScript, okay, from ES8, that helps you to program stuff asynchronously. Okay, so just to introduce you to the concept so you think about it, and then Monday we will go into details about this. A promise is just an object that represents a result of an asynchronous operation. Okay, and it basically tells you if everything was done, was finished correctly or not, and it can also carry a value, which is actually, let's say, the return value of the asynchronous operation. Okay? That in the previous case, for the callback, we had to put into the parameters, and that's why we also need to write the code inside the code following the callback inside the code of the callback itself. So, in short, we can solve the problem of asynchronous programming by making asynchronous operation immediately return an object of type promise, okay? And then having the system call a callback that we will pass when the object will have a final value that is the result of the asynchronous operation, okay? And we will have a way to chain, so put one after the other different promises, and so basically we solve this issue of executing one thing after the end of the previous one, okay? So promises are a standardized way to handle errors and provide a way for errors to propagate correctly to a chain of promises. So we can chain, put one after the other asynchronous operation and correctly handle both errors, in case there are errors, or values returned by the asynchronous operation, and pass them to the next operation. Okay? Okay. I will go back to the example just 1 minute. Okay, so I will commit this stuff. So you will see, I think it's, I mean, keeping this code just for me is a bit useless, right? So I will commit everything. Okay, so I will give you all the code, including the database and so on. And we will see the rest of the code except this query sync, which I don't like because it's just a trick, okay, to avoid the previous problem, you know, the nested calls. But I mean, just for your knowledge, but we don't expect you to use these tricks because with promises we solve the problem, okay? And you will see, and we will see together the code with the promises next time. Before we finish, just some information about you know, the SQLite format for the database. Okay, you see I clicked here, and I mean the Visual Studio Code opens the information about what's contained into the SQLite format. That's because I think I have an extension. Yeah, that's SQLite. Or this one, I don't remember, actually, I didn't check. Anyway, there are extensions here for Visual Studio Code, and there will be instructions in the lab how to install them, but it's very simple. I mean, you search for one, and you just need to install the right one. Again, be careful, they are external packages in case you have something sensitive and so on. I mean, you need to trust these extensions. And they are very convenient because they allow you to open, you know, this format, which is actually a binary format, so you cannot just open it with a text editor, okay? Or there's this program, DB browser for SQLite. Let me write it. DB browser for SQLite. Okay? That is a standalone program that you can install in any system. There's the Windows, Mac, Linux version. And this is very convenient because it allows you to do all the operation that you need to do on the SQLite format for the database. In particular, what you cannot do here in Visual Studio Code is create a new database. Okay? This is nice for inspecting stuff, but you cannot really edit the content of the database. With the other program, you can edit the content of the database. Okay, so you need to open the file, which is I think Wix2 DB exams, and unfortunately I cannot zoom in. I don't know how to do it. Anyway, you can inspect, but also modify stuff. Okay, just remember to save at the end. Okay. Yeah, there's some places where you need to save project, I think. Okay. Okay. So just be aware of the fact that you need to be able to handle this database. Okay, and there are tools to do that, either inside the Visual Studio Code just for inspecting, or outside to create and your database. Okay. I think that's all. If you don't have any questions, do you have any questions? No. So tomorrow there will be lab. Actually, with my colleague, unfortunately, I was supposed to come, but unfortunately, I cannot come again. But for next week, I hope I will be present, me, myself, for the lab as well. And we will meet for the lecture on Monday, okay, at 1 p.m. Room 29B, okay? Okay, thank you, see you.